methods. So methods could be either instance method or static methods. So we're going to look into both of those in this presentation. So what is a method? So method is a block of code, meaning it is a set of statements that could be invoked to perform some specific task. So we have seen examples of a method already, and the main method is in fact a special method. The following are characteristics of a method, so it can return one or no values. However, the method declaration should specify the type of return value. If the method does not return anything, meaning it doesn't return any value, then it should specify return value type to be void. And method could receive many arguments, or it could receive no arguments. So, by the way, arguments are sometimes called parameters. So we're going to use these two terms interchangeably. So why you want to declare methods in a class, and why you want to use method? Basically, when you are building an application, you want to break a large chunk of tasks into manageable tasks. This is a way of creating an application, dividing the larger task into small tasks. So what you want to do is that each small task will be captured as a method. Okay? So a class is basically a collection of methods with the properties, and so you can capture a domain class which has a larger large task, and those large tasks could be captured into smaller tasks, and each of those smaller tasks will be in a form of a method. Okay, as I said, there are two types of methods: instance method or static method. So we have some exposure to static method and instance method already. The instance method, sometimes called the non-static method. So instance method can be called only through an object instance, meaning it can be called only after object instance is created. So the calling syntax is the name of the object, so meaning it's a variable of object, a variable that points to an object instance, and then dot, and then you specify name of the method with arguments, of course. And instance methods are more common than static method. Now, static method, you do not have to create an object instance in order to call static method. And in fact, you can call static method by specifying just a class name dot method name. Okay, so we're going to see some examples of those using a string class. So string class and many other built-in Java classes have both static method and instance method, and string class is an example. So you can take a look at the Java API documentation of a string class. So let me actually go to this link, and you are going to see these are the summary of all the methods that you can call with a string class. So any method that doesn't say static, those are instance methods, like a char add and code point add and code pointer from and things like that. Any method that start with a static, those are static method. Okay, so it's pretty common that you are going to have both instance method and static method in your class definition. Okay, so as I said, any method that has static modifier is a static method, and any method that doesn't have a static modifier is an instance method. Okay, so let's talk about how you can call instance method. Okay, so the syntax is you are going to have a variable that points to an object instance, so like a name of that name of object and dot name of the method, and then you pass arguments. So let's see an example of string class. So we created a string object, new string, and then you provide some kind of string object as the initial string value. So we have string instance 1. So this represents object instance of a string. So now we should be able to call any instance method of the string class. So like a char at. So in this case, basically what we want to do is that we want to find out the character at third position, third character of the string instance. So it will be in fact I and space. It should actually return A, this A as a character. So obviously you can see char at, this should be instance object because it depends on a particular object, right? It should have some kind of a string object before being called. So char at certainly needs to be created as instance method. It doesn't make any sense to create a char at method as a static method because it needs an object instance, right? Okay, so if you take a look at the string class API, Java API, you are going to see a bunch of, again, instance methods and a bunch of static methods. And these are two examples of instance method. Char at, basically, we like to get the character of a particular index. Okay, so as I said, it is an obvious instance method. Another one is equals ignore case. If you want to compare a particular string object to whether that is equal to another string object, obviously this equals ignore case method needs to be created as instance method. It doesn't make any sense to to create the static method, right? You might in fact create a static method that provides both object instance. So in this case, this is actually the object is compared against the another string. So this one needs to be created as an instance method. Right? But you might in fact have a static method. So for example, like a public boolean, the equals ignore case with the two strings method. In that case, that could be a static method, and the arguments could be like the string 1 object and string 2 object. Those two objects are being passed as arguments. In that case, that method might make sense to be created as a static method. Does that make sense? Okay, so question from Joel. Question, why would you choose to create an instance of a static method or vice versa? Also, are there any benefits of using either? So we're going to actually talk about that in a few minutes, okay? Next question from Roger. How come char at 2 is equal to A? Why not space? Yeah, 2, that's an index. Index start from 0. Okay, so when you actually have a 2, that means a third position. Does that make sense, Roger? So in Java, the index is always start from 0. Okay, so these are the examples again. So we created a string 1 object in string 1, the string object, referenced by string 1, stl1 variable. So here we are trying to get the first character. So that should return H. So if you say 2, that should return L, the first L. Okay. Here we created another object instance of hello. And here we are using equals ignore case. So we are basically comparing the string 1 object with string 2 object. So in this case, this needs to be created as instance method because you are dealing with an object, string 1. Okay, so you are comparing whether string 1 and string 2, they in fact contains the strings, and because we are ignoring case, it should return true. Okay, if you're using just equals method, then it should return false because they are different. The cases are different, right? Here we are using equals ignore case method, which is ignoring a case. It should return true. Okay, so that is an instance method. Now let's talk about static method. Static methods are defined with the keyword static, as we have seen in the example of string class. So static methods are invoked without creating an object instance, meaning you don't have to create an object instance using new keyword. Okay? So you are going to call static method by specifying a class name. So you specify the class name and dot, and then static method name, and it could also receive arguments. Okay, so let's see an example. So we have used a couple of static methods already in our previous exercises. Remember parseInt? So parseInt is a static method of integer. So in fact, if you actually go to, let me just go to, so let's take a look at the Java documentation of integer. So let me just create the integer like this, and we are going to take a look at the Java documentation. And again, the integer has a set of methods, and some methods are, yeah, so this is bit count is a static method, byte value is the instance method. The one that we are looking at was parseInt, right? So parseInt. So this is the static method. Okay. And it makes sense to design parseInt as a static method because basically we are not really dealing with an object instance. Basically, all we want to do is just passing a string of some kind of value, and we want to convert it into just int primitive type, right? So there is no object instance involved. So that's the reason, parseInt method is designed as a static method. Okay. Another example is, suppose I want to get the hex string representation of value 10. Again, there is no need to have an object instance involved, right? So that's the reason toHex string is also designed as static method. Let's see. I think we have actually another slide somewhere that actually talks about the when you want to create a static method and when you want to create an instance method. I kind of touched upon those aspects already a bit, but we'll actually cover those things one more time, okay, in another presentation. Okay, so exercise 2. So let's take a look at the exercise 2. So exercise 2 is we have code, my static and instance method project. So my instance and yeah, so this is my static instance method project, and when you run it, okay, so it will just display a bunch of results. So let's take a look at the code. So we have created 2 instances of string class. One is through the new keyword, and the other one using string literal. And then we want to find out the particular character using char at instance method. Okay, so and then we just display those characters, and that's what we are going to see here, AIL. And then we invoke another instance method. So we basically invoke equals ignore case. So we are comparing string instance 1 and string instance 2. Okay, and then the value of, so that is basically another, it is a static method of string class. So you can tell whether this is instance method or static method by looking at the actual, the thing here. So if it is a class, in this case it's a string class, you can obviously see this is static method. Okay, so basically in this is a reverse of parseInt. We provide int value 23, and then we are going to create a string object from it. Okay, so when you actually display it, obviously that should actually return 23. Okay, and this is the one we have seen before, right? So we pass the string object, and we want to convert to int type. Okay, so in this case we are using parseInt. Okay. So when you build and run the application, this is what you're going to see. Now, I want you to modify the code and see what happens. So now let's try to actually call char at this is instance method, and you're going to call it like a static method. This is going to cause a compile error. Okay, so I want you to write this code and see what happens. Okay, you should actually experience compile error. So let me just do that here. I'm going to just copy this code, and yeah, I'm going to just do it right here. Okay, so you can see it caused a compile error. Cannot make a static reference to non-static method char at. Okay, so that is the error condition you are going to experience. You can take a look at the char at Java documentation. Okay, so we have done that already, right? So if you take a look at Java documentation, Shift tab 2 in the case of Eclipse, and you should be able to see the char at method. Oh, you should actually give that one. Let me just do char at Shift tab 2. Okay, yeah, so I was kind of expecting to see char at as a main screen, but anyway, so yeah, so in the case of NetBeans, it seems like it gives you char at right away. Okay. All right, so also I want you to try a few other the instance method and the static method of string class, and the character class, and the math class, and character class, and things like that. Okay. All right, so I'll give you guys about the 10 or 15 minutes to try exercise 2. Okay, so we talked about methods. Now let's talk about variables. These variables are sometimes called fields, properties, and attributes. So those are all same thing. So just like method, there are static variable and non-static variable as well. So static variables are sometimes called a class variable, and non-static variable is sometimes called instance variable. Okay. Now, there is another type of variable called the local variable, and this local variable is sometimes called the automatic variable. So these three types of variables are determined by where a variable is declared. And in the following slide, we'll see an example where all these three different types of variables are defined. And the type of variable dictates where and how it can be used. So it is in fact called the scope of a variable, and basically scope of variable is determining the visibility of that variable. So let's talk about these things in a bit more detail using an example. So this slide shows three different types of variables are declared. The first one is class or static variable. So just like a static method, in order to define or declare static variable, you are going to use a static modifier. Okay, so the private, static, yeah, we're going to actually talk about this access modifier later on. Typically, you want to define your fields or properties as a private. Okay, so private, static, and string type, and this is the name of the variable, and we are initializing that variable with Ford. Okay, so this is an example of static variable. Now, these are examples of instance variable or non-static variables. So these variables do not have the static modifier, so those are considered as instance variable. And another type of variable is a variable defined inside a method. So that's called a local variable. Okay, so let's talk about each of these three different types of variable in a bit more detail. Static variable or static field or static property. Okay, so static variable is declared inside the class body but outside of any method bodies. Okay, so that's the case for instance variable as well, as you will see, and it's prepended with a static modifier, and that's the difference from instance variable. Now, key characteristic of static variable is that it exists per each class. Okay, so in fact, static variable comes to existence when the class is loaded. Okay, and this static variable will be shared by all object instances of the class. Okay, so that is a static variable. And we're going to see an example of static variable in the following slide. Instance variable or instance field, just like a static variable, it is declared inside a class body but outside of any method body. So that is an example we have seen here, right? So they are both class variable and instance variables are declared inside the body but outside of methods. Okay? And instance variable exists per object instance. Okay, so different values will be set for different object instances. Okay, and instance variable comes to existence when an object instance is created. Makes sense, right? Because different object instance will have a different value for those instance variables. Make sense? Okay. Local variable, however, is declared inside a method body, and in fact is visible only within the method body. So you cannot actually use local variable outside of that method body. And local variable comes to existence only when the method gets executed. Okay, so in fact local variables are captured within a stack. Okay, while instance variables and static variables are captured as part of the class object or in object instances in memory. Okay. Any questions on static variable versus instance variable versus local variable? And we're going to actually talk about when you want to create a variable as a static variable and when you want to create an instance variable. Well, the guideline is pretty simple. When you want to have different values for object instances, then you certainly want to create it as an instance variable. If you have a field that should be common among all object instances, then you want to create it as a static variable. Okay? Now, if you want to have some kind of a variable inside your method, then you want to create it as a local variable. Make sense? Okay, so let's talk about scope of these variables. Okay. Yeah, the question from Sunu, can you call a local variable using an object? Okay, what do you think? Yeah, so I think the question needs to be rephrased. Can you call a local variable? You don't call local variable. I assume you meant, can you access a local variable using an object? Okay, the answer is no. Okay, so let's see examples of this in the following slide. Scope of variable. So scope of variable determines where in the program the variable is accessible. So it determines the accessibility. And it also determines the lifetime of a variable or how long the variable can exist in memory. Okay, so here it will actually, so no, we're going to actually take a look at examples of these things addressing your question. Okay, so the scope is determined by where variable declaration is placed in the program. So as you have seen the example here, the scope of this manufacturer static variable is actually as long as this class object, this class is around, as long as this class is loaded, this is available, it's accessible. This instance variables are only accessible when object instance gets created. Okay, this local variable will be existence only when this method is being invoked. Okay, so let's take a look at these examples in a bit more detail. Now, the easiest way to think about the scope of a variable is, basically the scope that was captured between curly braces. Okay, so basically code block. So more precisely, a variable's scope is inside the code block where it is declared, starting from the point where it is declared. Okay, so let me actually give you an example. So we have defined a class, okay, and then we have main method, right? So we have a main method. Now, these guys are all local variables. Do you agree with that? Because these guys are all defined within a method of main. So these are the examples of local variable, and then we want to actually see, you know, the scope of it. So the scope args. So args is obviously, in a sense, is an argument, and you can think of argument as a variable as well. So you can certainly access args within this main method, okay? But you would not be able to access args outside of the main method. Now, we also define the local variable I and j. So I, the scope of I is from the point it is declared to the end of the code block of main method. So this one and this one, yes, it looks like, yeah. It looks like there was actually some mismatch over here. I apologize on that. So I is actually visible within the main method from it is defined to the end of the main method. Same thing with j. J will be, j will be visible from the point is declared to the end of the code block it is defined, meaning this main method. Now, we created another artificial code block like this, right? In this case, k, the scope of k is from the point is declared to the end of that code block. So this is the visibility. So you cannot use k outside of this code block, okay? Now, m is the same thing, and n is the same thing. Okay, so these k, m, and n, they are visible only within this code block. Okay, but this I and j, it should be visible here as well, because I and j, the scope of I and j is from the this block. So I and j should be accessible in this code block as well. Okay, yeah, so that's basically what I just talked about in this explanation slide. Let's talk about another example here. So again, we are still dealing with, mostly local variables here, okay? So within the main method, we have defined ages, the array, okay? So this ages array should be visible within this main method, okay? But this ages cannot be accessible in another method, okay? Now, let's take a look at this for loop. So we have declared I variable within this for loop here. So I is only visible within this code block, this for code block, okay? And in fact, we have another for loop, which is using another I here. So this I is different from this I, okay? The scope of I, in this case, is this for loop, and scope of this I is in this for loop. So there is no conflict, okay? As you can see, we can access ages here, the ages, variable here, because that should be visible within this main method. Okay. Now we have another method called the test, and it has its own for loop. Again, it's using I as well. So this I is different from this I and this I. This I is only visible within this for loop. Make sense? Now, if we define static variable or instance variable here, then they should be visible in all these methods. Okay? Because that visibility is within this class block, so to speak. Yeah, so we just talked about this. Now, within a scope, there has to be a unique name. So in a single scope, single block here, you cannot define two different variables with the same name. So this is a compile error. Okay. However, you can have a different. You can have the same name in different scope. Okay. So in this case, we have defined test variable, static variable, in main scope here, okay, and then we have a local variable inside the main method. We have defined another block here. We define test, and this is perfectly fine because this test is visible only within this block, and there is no confusion in terms of which test we are talking about. So in this case, when we are accessing test variable, it is accessing the innermost the variable, so it will display 20. So when this is out, then this guy is going to access test, it will access this guy. Okay? So in this case, this test is different from this test. So there is no confusion. So there is no compile error. Does this make sense? All right. So question from a few questions. So let me actually address these questions. So question from Santi. Class level variables go to heap. The answer is yes. So both, the class level variable is captured inside the class object. Okay, so class object is a genuine object. So that object is going to be in the heap. Same thing with the instance variables. Instance variable will be inside the object instances, right? So those object instances will be in the heap as well. The only thing that is not going to be in the heap is going to be local variable, because local variable will be in the stack, not in the heap space. Okay. Next question from Sonu. Can you call a local variable using an so that question needs to be rephrased. So the answer is so the question should be, can you access local variable using an object? Okay. No, you can actually indirectly access it. You call a method, and the method will access it inside. You cannot access local variable directly in your code. Okay? Next question from Santi. Parameters and method level var go to, yes, I think we talked about that. Next question from Robert. Is memory freed up once code block it exists in ends? Yeah, so so I think the question needs to be rephrased from Robert. So I think what you're asking is that, is the method's going to be still in the class object, but the question I think you're asking is, is the local variable, once the method is done, is the method, let me actually phrase it. So I think what you're asking is the local variable is going to be freed up once a method is done? The answer is yes, because it is in the stack, right? So when a method invocation is done, then everything in the stack will be gone. So in that sense, it's actually freed up, okay? Hopefully I answered most of you guys' questions. Another question from Manny. Can we use a static variable test inside main method code block? Can we use static variable test inside the main method code block? There is also a test variable in the code block. Will there be any conflict? As long as they are indifferent. Yeah, so I think you're looking at this slide 42, right? As long as they are in the different scope, there is no, the conflict. Okay, so conflict happens only when you are trying to use the same name in a single block. Okay. Now I think let me actually see your first question. Can we use a static variable test? Yeah. So this test, inside a main method code block. Yeah. So that's what we did. So we are using this test guy right here, right here and here. All right. Yeah. So Manny, let me know whether that answered your question. Okay. All right. So let's move forward. Okay, so scope of variables. This is actually something that I talked about already. So, let's actually kind of review one more time. So local variable is only valid from the line they are declared on until the closing curly brace of the method code block within which they are declared. So it is in fact the most limited scope, and it's visible only when the method is invoked. And when the method is done, then it's gone. Instance variable is valid as long as object instance is alive. Okay. Class variable is in existence as long as a class is loaded. Okay. So the scope, in scope form, the pointed class is loaded into the JVM until the class is unloaded, and the classes are loaded into the JVM the first time class is referenced. Okay, so suppose I have, I'm gonna just call here so in this case, any static method of the string class will be loaded as soon as the string class is actually accessed. Okay, so you can see the local variable has the most limited scope. Duration of durability in terms of, so local variable is the smallest amount of durability, and the class variable is the longest amount of durability. As long as the class is around in JVM, static variable is around as well. Okay. All right. So let me see whether there are any other questions. We can't declare static variable inside the method. Correct. Static variable and instance variables are always outside of a method. Okay. If you declare variable inside a method, it automatically becomes local or automatic variable. Okay. Next question from, we can use it, but declaration needs to be outside of the method. Yeah. So I think that's a continuation of your previous question. Okay, so let's do the exercise 3. So exercise 3 is okay. So we are going to build my scope variable project. So let's actually my scope variable project. So let's run this guy and the Java application. And it basically display value of var1 is 10. Okay. So in this case, we defined the instance variable var1, and we should be able to use var1 here, as long in this code, right? Okay. So we are able to use a var1. Now inside this code block, we define var2. Okay. And then in this else code block, we define var2 as well. So this var2 is different from this var2, okay? Now, we should be able to access var1 inside this code. But if you try to access var2 here, that will cause a compile error. So let's take a look at this code. And, if you try to access var2, that is a compile error, because var2, the scope of it is just in this code block. Okay? So now, if you actually move this guy, so you're going to actually modify the code. So instead of having this var2, okay, inside this code block, you want to actually have this guy out. Yeah, we did that. So basically, this is the code I was looking at. So instead of having var2 declared right here, you declare right here as the instance variable, and then you should be able to access those var2 here as well. And now when you call the var2, that should be accessible as well, right? So, when you make that modification, things should work fine. Okay? Now 3.2 is you're going to write a Java program that declares 3 types of variables. So that is an example we have seen. So this is the static variable, this is the instance variable, and this is a local variable. Okay, and now we should be able to access the static variable, and we should be able to access the local variable, of course. And now let's try to access the instance variable here and see what happens. Okay. So 3 variables of, there's 3 variables. Okay, my 3 variables. Okay, so let's see if I just comment this out. That is a compile error. Okay. So cannot make a static reference to the non-static field in my instance variable. So this is a constraint. Inside your static method, you cannot make a reference to instance variable. Okay? Because by definition, static method should be able to be invoked without creating an object instance, right? There should be no concept of object instance within a static method. Okay? So if you try to access an instance variable within your static method, that is a compile error. Does that make sense? Okay. So that is the compile error that we just experienced. Okay. for your own exercise, introduce your own static instance and local variable with the proper values and print them out. If you have time, try this. Receive first names. Create a new project, or you can just use the existing project. Receive the first names of your family members, between 3 to 6 members of your family. You make up your family members. I assume most of you have a mom and dad, right? So, and then if you don't have any siblings, just come up with one. And you're going to receive those names. Then you're going to have a static method. Okay, generate new names, and you're going to generate new names by taking the second character of each string from the array of those names. So suppose you have siblings of these Rocky, Ashley, Oscar, Rina, and you basically take O and S and C to make the name of Oscar. Okay, so that's your homework. All right, so I'm going to give you guys about 10 or 15 minutes to finish the exercises.